Now we are going to look at another aspect of a geometric series, a case of finding the sum of a geometric series where the number of 10 is infinite. So our task here is to find the sum to infinity of a geometric series. Now, this is going to be feasible when the common ratio in that series is a fraction. For example, we have a series like this: 45, 30 plus 20 up to infinity. Now, this aspect is going to be feasible when the common ratio is going to be fraction or less than 1. Otherwise, if the common ratio is greater than 1 or a whole number like 2, 3, 4, as the case may be, finding the sum to infinity of that geometric series, the answer is still going to be infinity. So here is going to be a case of finding the sum to infinity when the common ratio is a fraction. And before now, we said that when the common ratio is a fraction, a suitable formula to use is S is equals to A bracket into 1 minus R raised to power n all over 1 minus R. This is a general suitable term for finding the sum to infinity of a geometric series when the common ratio is a fraction. Now, before then, I would like you to know one thing. If the common ratio is a fraction, say R is a fraction like 1 over 2, say R is 1 over 2, then we say n is equals to 1. It means that R raised to power n is going to be 1 over 2 raised to power 1, which is equals to 1 over 2. Where n is equals to 2, R raised to power n is equals to 1 over 2 raised to power 2, which is equals to 1 over 4. Where n is equals to 3, Rn is equals to 1 over 2 raised to power 3, which will give you 1 over 8. Now, you will observe that as the number of 10 continue to increase, the value of R raised to power n is decreasing. So it then follows that if the number of R continue to increase and tend towards infinity, the value of R raised to power n will continue to decrease and tend to 0. So why are we saying this? I'm saying this because at infinity, the formula will reduce to A into 1 minus, at infinity, the value of R raised to power n will be 0. 1 over 0 all over 1 minus R. So at the end of the day, you have A over 1 minus R. This will not be our suitable formula for finding the sum to infinity of a particular geometric series. So let's take an example. Let this be an example 1. Finding the sum to infinity, you just bring out the formula. Sum to infinity is equals to A over 1 minus R, where A equals to 45, the first term. R, to get R, normally as we have been doing it before, you take the second term divided by the previous number, which is 30 over 45. Now, by summation, reducing it to the lowest term, this one automatically becomes 2 over 3, reducing. So 30 over 45, reducing it to the lowest term, will give you 2 over 3. So our common ratio is 2 over 3. Then we can proceed. We say s to infinity is equals to 45 over 1 minus 2 over 3, which will give me 45 over 1 minus 2 over 3. If you do your sum very well, 1 minus 2 over 3 will give me 1 over 3. So this is now 45 divided by 1 over 3. So we are going to write it well, the way we will understand. It's going to be 45 divided by, you write it like this, 45 divided by 1 over 3. 1 over 3. So which will give me 45 over 1 times, if you change the division sign to multiplication sign, we make this 1 over 3 to be inverted, it becomes 3 over 1. Alright, so that at the end of the day, we will have 45 times 3 will give me 135. So the sum to infinity of this geometric series is 135. Here is another example. Example 2. Determine the sum to infinity of the geometric series 1 plus 1 over 2 plus 1 over 4 to infinity. To determine the sum to infinity. Okay. What we first of all do is this. The first term is 1. The common ratio, how do we get the common ratio? You take one term divided by the previous term, you have 1 over 2 divided by 1, which will give me 1 over 2. So the common ratio is 1 over 2. So having known that the common ratio is 1 over 2, we bring this formula, sum to infinity is equals to a over 1 over r, which is, the first term is 1 over 1 minus 1 over 2. So which will give me 1 over 1 minus 1 over 2 will give me 1 over 2, which is therefore sum to infinity is equals to 1 over 1 over 2 is like 1 over 1 divided by 1 over 2, which will give me 1 over 1 times, changing this multiplication sign to changing this division sign to multiplication sign, we make 1 over 2 to be inverted. You now have 2 over 1. Therefore, 1 over 1 times 2 over 1, that is 1 times 2, 1 times 1. The final answer is 2. So, the sum to infinity of this geometric series is what? 2.